Cool. So yeah, I'm Holden. If you want to follow me on Twitter because you don't have enough pictures of cats in your life, you can follow me on Twitter. And I'm going to put the slides from today's workshop and the talk I'm giving tomorrow up on SlideShare. So you don't have to take pictures of the slides, but if you do want to take a picture of one slide, this would be a good one to take a picture of, so you can find it. And if you want to connect and be all like business numbers, I'm also on LinkedIn like everyone else in the world. But like, let me know who you are if you add me on LinkedIn so that I can know it's legitimate business numbers. Yeah, so that I've already been introduced, so we can skip that. And let's look at, or did other people still want to get the picture of the last slide? Everyone? Okay, cool. So we're going to talk about sort of introducing what Spark is, specifically what PySpark is. We're going to talk about, how to get it set up. We're mostly going to skim through that and just do just enough to get through the workshop today, because like deploying Spark in a real production environment can be quite complicated, and like that would take more than a 2-hour workshop to cover on its own. We're going to talk about how Spark represents our distributed data, because I think it's a really cool abstraction. We have the mandatory word count example that must be included in every big data class ever. I asked if I could take it out, and they said no, they would take away my big data license. So it's still here. We'll talk about some PySpark specific things, which is actually kind of exciting to me, because I don't normally get to talk about these bits, because I normally give this sort of intro to Scala and Java people, and they get bored when I start talking about Python. And we'll look at using some different libraries with Spark. And if we have time, we'll talk about data frames, and we might even use some really simple machine learning stuff. So, I'm assuming that most people have some interest in Spark because you bothered to show up to this talk. But just in case you wandered into the wrong talk, Spark is a really cool general purpose distributed system. It has a wonderful API, and unfortunately, that's not why most people come to it. Most people come to it because it's really fast, and then they hang around because the API isn't terrible. Compared to writing MapReduce, it's like freedom. I compare it to like maybe Fortran to Python, but I've never actually had to do that migration myself. But it's a pretty awesome step up from traditional distributed systems. It's an Apache project. It's really active, which is both good and bad. It means it's being rapidly developed, which also means it's being rapidly developed. The core parts have API stability now, which is amazing. But some of the libraries, like the machine learning stuff, are still evolving pretty rapidly. So, those colors do not show up super well. But I'm not supposed to wander away. Okay, so at the bottom it says Apache Spark. And you can trust me that on top of Apache Spark, there's a whole bunch of really cool things. Today, we're mostly going to focus on, the core Spark along with SQL and data frames. Oh, there's a button? Ooh.
I did the morning tutorial.
Oh, now it's readable. Okay, thank you very much. Thank you. Okay, well, now you don't have to trust me. You can trust my slides, which also don't lie. So today, we're going to focus on sort of Spark SQL and data frames, as well as Spark Core. But like all of these things, except for the community packages, ship with Spark, which is really cool, because if you've ever had to make like an actual production pipeline, there's a good chance that you need to use a bunch of different components. And traditionally, these are all separate projects, which you have to glue together with something like Luigi, which I think there's another workshop on right now, which is a great approach, but I personally prefer to have all of my code sitting together. I'm really lazy. It's a blessing and a curse. Oh yeah, and some other cool things about having all of these things together as opposed to in separate projects. When Spark Streaming was introduced, there was a bunch of work done to make it so that tasks could get scheduled really quickly, because that's super important for streaming. But Spark SQL was able to benefit from this as well with sort of lower query times. And it's just this shared work is really awesome. So we can use like SQL within streaming, and even beyond that, like the fact that streaming got introduced meant that a whole bunch of stuff got made faster. So this is going to be our first sort of break to set up. I had this up on the slides before. If you're running Windows, you probably just want to go ahead and use the remote Azure clusters, which Microsoft has very generously provided to us. Someone pointed out to me that I put the links in wrong, and it's actually HTTPS in front of everyone rather than HTTP. So I'm really sorry about that. I should have double-checked that. My bad. If you can go there and just write your name down next to a cluster so that we don't have too many people all on like cluster 0, that would be great. We have a bunch of clusters. If you're running on Linux or OS X, you should feel free to go ahead and set it up on your local machine. It's a pretty good option too. Or if you already got it set up, you don't have to use the Azure cluster today. We're just doing regular PySpark. We're not doing any of the really fancy like HD Insight bits. But we're going to take a bit of time and just allow everyone to get set up and allow me to go and drink some more Mountain Dew. And maybe if the person sitting next to you is having some difficulty getting started, you can offer to help them because there's only one of me and there's a lot more of you. So we'll take like 10, 15 minutes and have everyone get set up. Probably closer to 10, unless I screwed up something else besides HTTPS. But cool. And if you get stuck setting up your cluster and you want to raise your hand, like I'll come over and help you. Okay, so hopefully most people are set up, and if you aren't, you can like sort of only half pay attention to me while I'm talking and continue doing the setup, and we'll circulate some more and answer your questions. You only need one of the remote or the local setups. If you did both, that's great, extra credit. Not that this really counts for credit, but you get all of the extra credit I can give you. So yeah, cool. So while we're going through the exercises today, there's a bunch of really useful links that I would keep open. There's the Spark docs, which have sort of this general programming guide, which is pretty useful. There's also the Spark PyDocs, which, it's pretty useful for checking the API. And I also have an IPython notebook up on GitHub with the examples if you ever get stuck. I'm pretty sure they're all there, and if not, I can add them. So just, maybe take a time for a few seconds to just open these in different tabs in Chrome or Safari or whatever, or in Internet Explorer. And I'll bring this slide back up once we're doing something again, so don't worry too much. So if you did go ahead and do the local installation, you can get it started with bin PySpark. This will give you a lot of log output because the default log level is info, which is an interesting choice. For today's class, actually keeping it at info can be kind of interesting because you can see what's happening underneath the hood with your transformations and when Spark is actually doing the work. But if on the other hand, you find that this log information is getting really annoying, there's this log4j properties template, and you should just update the root category to error, and then you won't get all of these wonderful warning messages. If you're doing this in Jupyter on Azure, everything's great. You don't have to do this. Don't worry. Yeah, don't script the password. If you're just at the cluster link, scroll up and select notebooks, and then go to Jupyter. We could reconfigure the clusters, but let's not do that because we probably have multiple people on the same clusters, and let's not step on each other's toes today. So we're going to start off by talking about the Spark context. And the Spark context isn't the most exciting part of the Spark world, but it's sort of our entry into things. If you've looked at the HVAC tutorial in the Jupyter, you can see one of the first things it does is create a Spark context. The main thing that we use the Spark context for is creating RDDs, Spark's distributed sort of data collection. And we'll talk more about how they behave in a bit. But that's the main thing that you're going to use the Spark context for. You can create counters. You can also do broadcast variables. The Spark context can be used for more than just creating RDDs, but that's its main use case for today. If you're running in the shell, if you run bin PySpark, it's going to automatically create the Spark context for you. If you're running this in the Jupyter notebook, you have to create the Spark context. And some people have already noticed that we can't have multiple Spark contexts at the same time. And if you run into this problem, you can just run sc.stop, and that will shut down your existing Spark context, and then you can rerun the cell which creates your Spark context. The Spark context is also where we sort of specify which cluster we're connecting to. You see this in the HVAC example in the Jupyter notebooks where it's pointing to the head node. We can also point it to yarn and other things like that. For today, just use the defaults and it's going to work pretty well. So if you already deleted the HVAC example from your Jupyter notebook, this is how you can create the Spark context really quickly. If you didn't, you can just use the one from the HVAC example. So with that sort of preliminary stuff out of the way, we're going to talk about RDDs. And RDDs are like where I start to get really excited about Spark as opposed to just changing configuration entries. RDDs are resilient distributed data sets, and they take a really different approach to achieving resiliency than is often done in distributed systems. So things like Hadoop MapReduce tend to achieve resiliency by storing the output in multiple places so that if the node that did the computation goes away, it's okay, it can just go and read the data from somewhere else. But if anyone remembers, spinning disks are really slow, and even SSDs are pretty slow. And Spark instead handles failures through recomputing the data. And it's actually really smart. Spark is able to only recompute the parts of the data that it needs to. Since our data is spread up on multiple machines, if we have sort of narrow transformations, that's like if we're doing things like a map or something, where like our data only depends on this very specific previous subset of data, it will only recompute the minimum amount required. So that's pretty awesome because recomputing everything whenever you have a single node failure would obviously kind of slow you down. Part of how Spark implements RDDs is through lazy evaluation. And I normally like to think of a panda, and I'm pretty sure I have a panda in a few slides. So we have this panda for our lazy evaluations. So what that means is we're not going to do the work when we ask Spark to do work for us. It'll just be like, oh, no, man, I'm just going to wait on that until I actually need to do the work. So if we took an RDD and let's say it contained lines of text and we wanted to split it up into words, we wanted to tokenize it, Spark wouldn't actually do any of the tokenization until we did something like count the words or save the result to a file. And this is really cool because not only does it allow us to have this really cool graph structure, Spark is able to use this really cool graph structure to reduce the number of times it's going to read over the same data. So it does this really awesome pipelining where it sticks a bunch of operations together. And that's pretty cool because one of the traditional challenges in distributed systems is figuring out which operations I need to stick together into the same really giant ugly mapper. And instead, Spark just does that for me. And so I'm really stoked about that. But that's enough sort of rambling about the theory of RDDs. Let's look at, making a really, really simple word count example that I, have to do or they take my big data license away from me. So the first thing that we do is we make this RDD of lines. And so what that means is that we have this really cool distributed collection, and it consists of just lines of text. So sc.text file gives us a really convenient wrapper to load in text data. We can load in any other types of data that are supported by Hadoop, and we don't need like a Hadoop cluster, it just can understand that stuff. But this makes it really simple for handling text data. The flat map and the lambda function inside should be pretty familiar since we're all like Python people. And then we have this word count example, which is actually incorrectly formatted because I'm the best at slides. And what we do is we take each word and we put the number 1 next to it. And then we have this reduction, which says I want to take all of the things with the same word and I want to sum the values. And this is really cool because it's lazy, and this reduce by key actually does a whole bunch of really cool things behind the scenes. If you're coming from MapReduce, and I know I keep talking about it, and it's not that I hate MapReduce, I love it, it's just I think Spark is more awesome, it automatically does a map-side combine. So what that means is before it goes ahead and shuffles the data across the network, it figures out, all of the things with the same word that happen to be on the same machine that I'm processing at the start. It'll do that reduction first. And it does that automatically for us. And then, later on, it'll do the shuffle, and we'll have much less network traffic, which is cool because network traffic is kind of expensive. So as I was saying, Spark is lazy. And our magic line of laziness is right above save as file. All of the things prior to it are lazy transformations. Text file, maybe not a transformation since it's not taking an RDD and giving us back another RDD, but it's still lazy. We don't actually read the data until we go ahead and save the output, which means you can write like a really, really long, giant transformation, then go ahead and like do your action at the end and find out that the data you were doing it on doesn't actually exist. So it's good to do things in things like notebooks where it's really simple to go back up and change something. Otherwise, you'll find yourself, being kind of sad sometimes. Another thing that's really important to understand while we're looking at this example is that all of these operations are actually giving us back new RDDs. We're not transforming the existing data, we are, but it doesn't change it in place, right? So lines is still just an RDD of lines. So it's actually pretty common in Spark to read in some data and then do a bunch of different operations on it, and we'll have this shared common lineage, and that's totally okay. And it's actually really great because we can use caching to make it extra fast. Yeah, cool. So, this is our wonderful panda with some pretty common transformations, especially if you're coming from a functional programming background. We've got map, which allows us to produce a new value for every input value. We've got filter, so that we can only process the lines which talk about how awesome we are. We've got flat map for tokenizing things. Reduce by key is pretty neat, so that we can actually combine values with the same key, distributed systems. And join and cogroup are actually also transformations. Even though they work on multiple RDDs, they're still transformations. They're taking in RDDs and giving us back RDDs, and they're lazily evaluated too. So they won't explode and give us an error message until much later. But at the same time, it's able to do a lot of sort of optimizations around this. One thing to understand about the first few transformations is that they're narrow transformations. And what this means is that since the output data has a sort of very direct mapping to the input data, Spark is able to really easily recompute data when it gets lost. So if a worker node fails and we lost some data from a narrow transformation, we have a really small bit of recompute to do. But joins, we might have to recompute a lot of data. So sometimes it can be a good idea to like cache stuff on multiple nodes after doing joins if you're going to be doing really long-term computation. So actions are our eager beaver, and I'm Canadian, so I like this beaver. So count, reduce, collect, take. The important thing to note is that reduce is an action and reduce by key is a transformation. That's because reduce is going to return a single value to our driver program rather than returning another distributed collection. Collect is great. It brings the values back to our driver and then makes it promptly fall over because we tried to bring a terabyte of data back to a laptop. But it's really useful in unit testing. If you're doing other, sort of more production type stuff, you're probably more interested in take, where you can grab a few things, and there's also take sample if you just want to sample your data. The actual output mechanisms that you probably want to use are like save as text file, and then there's also save as Hadoop. Although like the saving to sequence files from Python is a little funky. But so like saving to JSON is probably like a much better idea than trying to do the Python sequence files. They're a little weird. And count by value is great. It's like collect in that we could make our thing fall over, but we might not if we don't have too many distinct values. It's the Russian roulette of Python programming. So, okay, with that, I've given you like an incredibly fast introduction to RDDs and only a few transformations and actions, but we're gonna exercise like this dog, which is jumping over two pretty low bars. But you know, it's actually gonna be challenging for us because it's probably our first time doing it, just like I imagine is this puppy's first time jumping over those two bars. So we're gonna go ahead and we're gonna find all of the lines with the word Spark. And then we're gonna count them. And so this is the first part, and this is the part that just, you know, so that we can all be working from the same input data. Normally we wouldn't be reading it from a file, right? We'd be reading it from a distributed file, but I was kind of lazy and I didn't want to put a big data set up for us to work on, and I also wanted things to move quickly, so we'll do it from a local file. But this could just as easily be data on HDFS. So yeah, go ahead and let's find the lines with the word Spark, and I'll jump back a few slides to the links that we can use if we get lost on what sort of transformations and actions we might want to use to do this. If you're doing this in the Azure cluster, feel free to do this on top of the HVAC tutorial. Just make sure to do it with a new cell rather than in the same cell that is creating your Spark context, because we can only have one Spark context at a time. Or you can, you know, do the work to create your own Spark context in a separate notebook. Either way is fine. How many people have a word count for the number of words in Spark? Sorry, for the number of lines with Spark. Okay, cool. How many people want 5 more minutes? Okay, I'm sorry, there's only one of you. We'll look at the solution, and you know that should help. Solutions tend to help. So, I mean, this is one of many solutions. You can write your Lambda function in different ways. And this will be in the IPython notebook as well if you want. So what we're doing is we're reading in our data, and then we're filtering for only the lines which contain the word Spark. And then we're calling count. Now we could call collect and then do like a count on the array that we get back. That works because our data is actually pretty small. But you know, generally we might have larger data. So calling count is better because what happens is each worker will figure out the number of entries that are there and only return the number of entries to the driver. And that'll definitely fit on the driver. And we could also save an RDD out. You have a question? Oh yeah, that's a typo. Thanks. Do. Oh, damn. Ah. Okay, cool. Now with slightly less typos. Sorry if the typo was tripping anyone up that was looking at the slides to get ahead. Sorry. So one thing that we could do is we could combine this solution with also doing another thing on that same file, right? Like we could count the number of lines not containing Spark, or we could, you know, count the total number of lines. We could save the word count. We could do all of these things. Now, admittedly, I do have the answer up here, but does anyone want to pretend that they haven't read the slide and say, you know, what they think might happen? You have to not be looking at the slide to pretend you didn't read it. Okay, no one wants to do that. Okay, but so essentially if we do 2 actions on the same RDD, or we do two actions on different RDDs which share the same parent, we'll actually end up doing the work to compute that parent multiple times. And like, that's not great. You know, it'd be cool if like that was magically figured out for us. It's not currently, but for now, if we know that we're going to be reusing the same data multiple times, like let's say we're training a linear regression model, we know we're going to be iterating on our training data set a few times, we would go ahead and we would cache that data. And caching is awesome. We have a few different options for how we can cache our data. We can cache our data in memory, which is great because it's really fast. We can cache our data to disk, which is cool because there's a lot of it. Or we can cache our data in memory and disk, which is great because it's really fast, but if we run out of space, it's still there. And it's normally faster to read the data from a local disk than it is from, say, HDFS. This isn't always true. If your cluster has especially terrible drives, you know, never cache to disk, but maybe get a better cluster. Whatever. And the third option is checkpointing. So if we're doing like really, really complex work, right? And it would be so bad if we lost a node to recompute this data, we can actually do what sort of MapReduce would do and write it out to HDFS or a persistent store. And this is actually really useful in some graph type computations, because when you're doing these really, really long graph computations, we're building up this giant graph of all of the information that is needed to construct this RDD. And keeping that in memory can get kind of expensive. But if you can put it in like this persistent storage space, Spark can just forget about all of that stuff. And then you can just keep working from this persistent storage going forward. So, you know, a little bit of a side note, but I'm talking so I get to make side notes. Yay! Okay, so if we pretended that I hadn't put the answer on the previous slide, we could, you know, investigate this with 2D bug string. And this is actually something you can do on the RDDs from the previous exercise that we were doing. You won't be able to do this on the collected or counted value because that's a local value, but on any of the distributed collections, the RDDs, you can do 2D bug string, and we get to see this information about where our data is coming from, right? So we can see here that my home directory is home Holden, not the most imaginative, but like you can see what your backing path was for all of your data. We can see that there's a shuffle involved, right? And you know this is interesting. It's not super interesting for word count, to be fair, but for other things it can be much more informative when things are behaving weirdly and you don't know what's going on. So this is with a cached version. You can see we have this information about, you know, we cached 2 partitions. This is the amount of memory it took, etc. I haven't really talked about partitions too much, / at all, because we can write code and pretend they don't exist. But if anyone's been wondering sort of how Spark decides where the data goes onto different machines, there's this really cool thing called partitions. And by default, you know, Spark will try and when you're reading in the data, read it in from a node that is close to the node with the data, and it'll distribute this on like a bunch of machines. But if we like are doing a bunch of joins between data, we can specify like a certain partitioner, and then Spark is able to use that information to make our joins super fast. And there's a bunch of other reasons to do custom partitioning, like secondary sorting, but you know, we don't have to worry about that today. Cool. So it's time for a detour into the internals, and proof that I know how to use Flickr's licensed for commercial use filter. So we've actually already explained most of what lazy evaluation is, and some people have probably already come across the last problem, right? How many people got error messages that were pointing them to not at all the right line while they were working on this? I know there was at least one of you. Can you raise your hand? Okay, two. So, okay, for a program this small, it's pretty simple to figure out where things are going wrong, right? Like, there's just not that much going on. But, you know, the lazy evaluation with a really big program can make it kind of tricky to figure out where things are actually failing, especially in Python, where the error messages are a mixture of Python stack traces and Java stack traces, which is sometimes confusing, even to me, right? And I work on this sometimes. I find it's really useful to like do a take one or head on some of the RDDs when I come into like a failure and I want to try and figure out like what is actually failing. Use that as you may. We've talked about how Spark is able to do the pipelining and how that's really awesome, but like the pipelining is more than just making stuff fast. It actually makes some things possible that, it makes us writing bad code possible, which is good because bad code is often faster. But what I mean by that is like, we can write things which would result in materializing stuff which is too big, and provided that we're doing these right kinds of transformations, Spark is able to just like put it together and like do really intelligent pipelining. This is cool, especially when we're dealing with things which are difficult to serialize, because there's some serialization restrictions. This comes up more in the Scala side than the Python side, but if anyone converts you to the dark side of the JVM, remember this. So we ran some code, right? And we didn't put a cache in there, but I'm going to pretend that we did put a cache in there. And let's look at what's happening. So, and I'm also going to pretend we're reading in from a distributed data store as opposed to local machine. So this is not exactly this code, but some code. So our driver program is going to like take our work and it's going to serialize our function and send it across to the worker. This can actually be like an interesting source of bugs. If you ever write code and you start getting serialization errors, there's a few chances of things that could be going wrong. You could be trying to return or read something that isn't serializable. Or if your function is referencing like something in your outer class, Spark will try and grab that entire class and serialize it. That works like some of the time, but it's kind of slow. And other times it'll also fail because your class like has some non-serializable elements in it. So that's something to watch out for. So we send our function to our workers. Our workers are going to read a bunch of data. They're going to send the counts back. And they're also going to have this little cached partition. And this cached partition could be living in memory, could be living on disk, depending on what we said. We could also, if we're worried about node failure, ask Spark to cache the data on multiple machines. And this will still normally be faster than checkpointing because writing to another Spark worker is generally faster than writing to HDFS. But so that's pretty simple. And the cool thing is, now if we went back and we did like the same operation or we did something similar, we wouldn't have to read the data in again. Cool, okay. So now I get to do something that I don't normally get to do, which is talk about PySpark internals. So Spark is primarily written in Scala, but we're using it in Python. How is this magic working? And it's not Jython because our code is running. Or more specifically, we're able to call like pandas libraries and stuff like that, like useful things that might not be available in Jython. And so Spark does this by starting up native Python processes and then using Py4j. How many people have used Py4j? I'm sorry to both of you. But Py4j, when it works, is really pretty simple. Conceptually, you can think of it as just like making a pipe, and we're asking the JVM to do things for us sometimes, and the JVM will, if it's feeling in the mood, send back some data or a stack trace. So that's sort of how the integration is done there, and that's pretty cool. But Spark still needs the data to live in the JVM, right? Like all of our shuffle operations, all of our caching, all of our partitioning stuff, that's all done in Scala. So we use pickling. How many people have pickled all of their data? Once again, I'm sorry to about 3 people. So we can think of it as like serializing all of our data. So like if you've, you could think of it.
For cross-process communication?
Yeah, we're actually using pickling for our cross-process communication. pickling everything is kind of slow, right? We're having to take all of our stuff and serialize it and then deserialize it repeatedly. The cool thing is Spark SQL actually avoids some of this, which is pretty cool. And Spark SQL and data frames are going to use those terms interchangeably because Michael isn't in the room and he won't like glare at me. But if he's watching the YouTube video, I'm sorry. But anyway, so Spark SQL lets us work with structured data, and this structured data lives in the JVM land for as long as possible until we actually need to do something really Python specific. So until we're doing like a Lambda function on it. So we could do our filters and stuff, you know, if they were simple enough and still keep the data in the JVM. We'll skip this, yeah. So I've been talking about how we can use other libraries, but we haven't actually used them today. And realistically, we're probably not, because there's only so much time. But there's a bunch of different libraries that we can use with Spark, right? In addition to the things that Spark itself ships with, there's a wonderful collection of libraries on sparkpackages.org. And I'm not saying this just because I have a package on sparkpackages.org. I actually use other people's packages from there. There's things like reading in from different file formats. There's stuff like making it possible to test your code, which is cool. Testing is awesome. And there's tools to do like different types of like machine learning stuff that isn't maybe an ML lib yet. So Spark Packages is a great source. But I mean, we're all here because we like Python, right? And we're probably familiar with Python tools rather than Spark tools. So we should try and use those tools when we can. So we've got a few options to make our Python packages available. One option is, honestly, and it's if you control your cluster, just pre-installing it on all of your worker nodes is a pretty good approach. It works like 80–90% of the time. The other option is if you have like a zip file or egg distribution of your Python stuff, you can add it with, you know, specifying zip files when you're starting your PySpark job. If you're doing it in Jupyter or something like that, there's also some parameters that you can set that are similar, and you can find them in the documentation. And the other one is you can also dynamically add more Python code with sc. Oh wait, no. That is not right. It's not sc.addFile, it's sc.something. I'll correct that on the slides when they finally go up. But you could use addFile, I guess. Just don't. There's something better and it'll be on the finished slides. I'm sorry about that, typo number 2. But anyways, yeah. So there's a bunch of ways we can go about, you know, using these other libraries. If you've got it, you know, if you got your cluster and you have admin access, just pre-install it. It's just so much simpler. So we're going to go ahead and we're going to take Spark's data frames out for a spin. They're amazing in quite a lot of ways, but it's really important to remember that they're not really maybe what you would have come to expect if you're coming from R or Pandas. Like the operations that we can do on them are not as full-featured. Relatedly, I have a talk tomorrow on how to do more awesome things with Spark data frames using sparkling pandas. If anyone wants to come to that, you know, I think it's cool, but I'm obviously pretty biased. One of the things that I love about Spark data frames, and I mean this is kind of silly, but it has saved my bacon so many times, is support for schema inference on JSON. How many people have to work with structured JSON data? Man, a lot of people in this room are really lucky. Normally, way more people are having to work with terrible data formats. But if you're having to work with structured JSON, which no one bothered to write down what the format was ever, Spark schema inference on JSON is amazing. You can just point it at that, like, your giant JSON for like 2 years worth of server logs, and it just, it's amazing. I'm sorry, I can't. It's just saved me so much time. It's hard to not talk about it, even though there's only a few people it'll benefit. So the final thing is that we access Spark data frames through the SQL context. If you were looking at the HVAC example, you notice that after we made the Spark context, it was making the SQL context. So we'll do something similar. Oh, yeah, let's not use this one. So data frames aren't quite as lazy as RDDs. And part of this is the magic of schema inference, right? Like when we're loading our data, data frames are structured, so they try and figure out some of the schema information. What this means is, you're not going to get an error message that the file that you thought you were processing doesn't exist, but it won't be quite as lazy. Like you'll see some computation happening as you're going, but rest assured that it's actually delaying most of the computation. Yeah. So here's some sample JSON schema as inferred by Spark. I mean, not the prettiest thing in the world, but compared to staring at like 100 records and trying to manually guess what it is, oh my God. So we can get this by calling print schema on a data frame. And we can do this with more than just JSON data. It's just JSON data tends to be especially like gnarly. So we've got like some different ways we can manipulate data frames. We can go ahead and actually just write pure SQL against it. How many people know SQL? Finally. Okay, the first time there's more than like 3 hands going up in the room. Okay, cool. How many people like SQL? Cool. Okay. There's some people on the fence, but like, compared to Fortran, how many people like SQL? Oh wow, less people. Okay, sorry. But Spark SQL lets us take these data frames and we can write SQL queries against them. So as you can see, I like pandas, and I especially like this panda ID. I don't remember what it is, but that's the one I'm looking for. The other option is we can write things with this sort of more programmatic style API, and this is just a df.filter, and it works like normal. But it's pretty cool because, and like, don't hate me for saying this, the data doesn't have to come to Python. And it's not that I don't like Python, it's just that I don't like serializing objects. So we're able to do this operation while keeping all of our data in the JVM, narrow it down to something much smaller, and then work with it in Python. So I think it's pretty cool. Yeah, okay, cool. So that being said, at some point, we're all Python programmers. We're probably going to want to write some Python code. So we can actually just call map on it. And so we can go ahead and, like this says, I'm getting the text information from each row. And this just gives me back a regular RDD, right? Like it's no longer a special data frame. It's just an RDD, and all of the things we were doing before will now work on it. If we have an RDD, we can also convert it back to a data frame, or it doesn't even have to be from a data frame. We can manually specify a schema or have Spark magically infer a schema for us. We can also make UDFs, right? That's another option for when we want to run some Python code on top of our data frames. And I mean, this might not look that pretty, but compared to writing a Hive UDF, this is amazing. How many people have written a Hive UDF? Oh man, tough crowd. Okay, so trust me when I say, even though we're having to specify our return type here, this is way better than having to write UDFs in many other sort of distributed systems, right? We just write some really simple Python code, we say what our name is going to be, and we say this is our return type, and it's just magic. Cool. So it's time for one more exercise and me to go get some more Mountain Dew and probably something from my throat because I've been talking way too much. I'm sorry. We're going to go ahead and write a UDF to compute the length of a tweet. This isn't actually really going to be a tweet. Like it's, well, it'll be one of my like useless tweets. But we're just going to write a UDF to compute the length of a string. Yeah, cool. So that being said, right, I'm asking you to do something, but we don't have any tweets right now, right? Like, unless you work at Twitter, in which case, let's talk, I want some of your data. We need to collect some tweets. So we've got some options to get some tweets. The first one is if you have your Twitter credentials handy, there's a really cool Spark streaming demo, which will actually just go ahead and collect some tweets for us. So if you want to play around with that, be my guest, and we can chat about how that works. Normally, we'd have a bunch of tweets collected on HDFS. I'm pretty lazy, though, so I'm just going to have you get them from my GitHub. Well, actually, from the Databricks GitHub. So, yeah, we can do this. So let's walk through this code. The first part is importing URL-lib2, which should be pretty familiar. Then we just go ahead and fetch it. We're not using Spark yet. I'm printing out the data to make sure that I actually got some data. And here I'm saving it to a local file. In this case, actually, this is a really specific one. You can see magic 2 is probably not actually where you want to save your data. But you can just go ahead and save it to a local file. Or there should also be some information in the spreadsheet. And if there isn't, I'll go ahead and add it right now. About where your distributed storage is, and you can save it to the distributed storage, and then just work with this like normal. You'll note I haven't actually showed you how to load the JSON data. So this is one of those examples where we get to look at the documentation and figure it out. I'm both optimistic and scared, but I think the Spark documentation is pretty good, and we should all be able to figure this out from the docs. And if we can't, no worries, just raise your hand and I can come help guide people in the docs. And I'll probably go ahead and update that spreadsheet right now with people's storage credentials. And then I'll go get some Mountain Dew. So the storage info is in a separate tab on the PyData PySpark clusters doc called storage info, and I'll put some paths on there. One thing to keep in mind is with Spark, when we go ahead to save a file out, it won't by default overwrite an existing file. So put your name or something in the path that you're writing it out so you're not stepping on each other's toes. So one option is we don't have to specify the full path. We can actually just specify the file name and it'll get written to HD Insight. I forgot about that, but it's awesome. It's super happy fun times. So if you were getting lost trying to figure out what your credentials were, just go ahead and save it to just a file. And don't put file : / in front of it. That'll try and save it to local disk, and that's not what we want. Okay, so we're getting close to the end of our wonderful time together. It's been great hanging out with all of you, and you should come and find me more. I have pretty distinctive hair, so I shouldn't be the hardest person to find here. But there might be another person with rainbow hair, so double check. My name is Holden. Before we all run away, I wanted to talk about some additional resources so that you can continue your adventure with learning Spark, because I know you are all incredibly excited and want to learn more about Spark. So we've been looking at the docs a lot today. They're pretty good. There's also some books, and I'm a little biased because I've written some Spark books. I think they're all excellent, and everyone should own several copies. But yeah, let's look at some of the stuff. So the Learning Spark book is one of the books I co-wrote. I think it's really good, but obviously I'm incredibly biased here. There's also fast data processing with Spark. Make sure you get the second edition. I get less money when you get the second edition because someone else like updated it, but the first edition is like terribly out of date. So unless you are like interested in learning how Spark's API has evolved over time, you probably want the second edition of Fast Data Processing with Spark or the Learning Spark book. Both are on the really new Spark stuff. There's a wonderful advanced analytics book by Sandy and some other wonderful people at Cloudera. And Spark in Action is supposed to be coming soon. I know they switched authors, and I don't actually remember who the new people are, but it'll probably have pretty up-to-date API coverage once it comes out too. So that's another thing to look at. We're all at a conference because conferences are awesome and an excuse to get out of our workplace. There's some other fun conferences coming up and meetups too. Strata and Hadoop World in New York. I'll be giving a talk there. I wasn't able to convince my employer to send me to Amsterdam, but if you can convince your employer to send you to Amsterdam, more power to you. There's a Spark Summit in Amsterdam, and I will be really jealous. Please send me pictures. There's also a Seattle Spark meetup. I've never been, but I assume it's pretty good. It looks kind of cool. And there's a lot more community events as well, also on the Spark website. There's a bunch of videos on Apache Spark. There's this YouTube channel, which is pretty good. It has a lot of the things from the previous sort of trainings and also previous talks on Spark. There's training at Spark Summit, and there's also a video of the 2014 training. Things have changed a bit, but not that much. It's still pretty good. Paco also has a wonderful introduction to Spark, which is great if you have $100 or an expense account. It's pretty good too, and you can get it from O'Reilly. And yeah, that's pretty much it. Thanks for hanging out with me for 2 hours. I know it's been a long time. I really want to thank all of the people from Microsoft. If you want to come up maybe and say who you are, that would be cool, but you don't have to. Oh, that's a no. Yes, yay! The Microsoft people have been super awesome and helpful with getting our clusters set up. They gave us this cluster space for free. They're amazing. Do you maybe want to like? How do we turn this on? Oh, I think it's good. Okay.
Yeah, so I'm Alejandro, and I'm working on HD Insight, which is the team that provided the clusters that you were using today. If you have any feedback, please let us know. And I hope that everything worked for you.
Hi, my name is Judy. I also work on the Spark crew, and I'm a Spark contributor right now. And yes, we are love feedback from you guys to make our product much better. Thank you.